Okay, grade 12. So we're on question 2, and 2.1 says, consider the geometric series where 4, 2, 1, a half. So as you can see, they are being cut into 2 the whole time. So 4 divided by 2 is 2, and 2 divided by 2 is 1. So since that is happening, they're really just being multiplied by a half each time. So 2.1.1 says, does the series converge? Justify your answer. So does this converge? Well, for a series to converge, your ratio needs to be greater than -1, but less than 1. Okay, so that is just the answer in like a equation sense. We can go into a more detailed explanation on that, but I think maybe I'll speak more about that in another video and what it really means for a series to converge. So remember what I said the ratio is. So that's really all you have to do here. Find the ratio. So the ratio you could find by saying the second term divided by the first term. And that gives us a half. So we know that a half is greater than -1, but it is smaller than 1. And so therefore the series does converge. Okay, so that is 2.1.1. Moving on to the next question. The next question, they want us to find or calculate the sum to infinity. So you just need the formula. The sum to infinity is equal to a over 1 minus r. So our a value here is our first term, which is 4. So that is 4 over 1 minus our r is a half. And then if we calculate this, it's really just 4 over 1 minus a half is a half. If you say 4 divided by a half, you're going to get 8, and that is your answer. Okay, moving on to the next question, 2.2. Okay, so question 2.2 says, given, and we have a case of sigma here. So sigma just means sum. Given the sum, starting where p is equal to k and ending at 10, of a series with this formula, 3 to the power of p minus 1, given that sum, okay, the sum of that series is equal to 29,520, we need to calculate the value of k. Okay, so this one is a little different because they put k here instead of on here. So it's just something that's a little different, but let's just try to look at it the way we would normally look at a sigma question. So they want you to find k, no problem. Since this is sigma, it's speaking about the sum of a series. And this is the sum of what type of series? Well, you have 3 to the power of p minus 1. And as you can see, your variable is on your exponent. So it means that this is a geometric series. Okay, so now that we know it's a geometric series, let's also just understand a few things about this. When you have the sum, the number that they have here is the value that you're going to start with. Meaning, in order to get your first term, you would take the value that they gave you here and you would substitute it in place of your variable in your formula, right? And then the number here is where you're going to end at. Again, you'll take that 10 and substitute it into there to get your last term in this series. So since they're still asking us to find the value of k and we know it's sigma, let us look at the formula we have here. Since our formula is 3 to the power of p minus 1. Okay, so this is the Tn formula, or let's call it the Tp formula since p is our variable here. So since our formula is this, let's compare it to the original, the general formula of a geometric series. And that formula looks like this. Tn is equal to a multiplied by r raised to the power of n minus 1. Okay, so if that is the case, let us just see. Do you see that you have p minus 1 here and n minus 1? So that's a good thing because now it means that they're really in the same format. And now, based on that, we can actually find out what r is. But here's the thing. If we can see that, okay, this is r, clearly, why can't we say a should be 1? Since that's the coefficient of the 3 here. Okay, there's an invisible 1 there, technically. Now, the reason you can't say that is because with sigma, they tell you where to start. Okay, they tell you p is equal to a specific number, and by default, that has to be your a value. That has to be your first term. Okay, so let's not make that mistake and call that 1. So what we can do here is, since we know what r is, let's actually focus on the main goal. The main goal is to use the sum formula to find k. because this is sigma, okay? It's the sum of the series. So the sum formula, since we know R is 3, I'm just going to say that R is equal to 3. So since we know that, so you see R will not change. There's no confusion in that. As long as it is the thing with the exponent and it is in the same format, then that is R. So our sum formula is Sn is equal to A multiplied by R to the power of n minus 1 all over R minus 1, okay? And let's just figure out everything we need to find here. So in order to find K, we need to know what N is, we need to know what A is, and we need to know what R is going to be as well. Now N, I always mention this, I've mentioned this a lot. N, please note, N does not stand for the number that you end at. Many a times it will be the number that you end at, and that's only in situations where, let's say, P is equal to 1. And then in this situation, right, N would literally just be 10 because there are 10 terms. From term 1, from P equals 1, 2, 3, all the way to 10, there will be 10 terms. But once they change this, it's a little different, okay? So how I want you to see N is the number of terms, but how you find it is simply by saying you take the top, or let me actually stop calling it the top. Let's say you take the number that you end at and you subtract it by the number that you start at and you add 1. That's how you find N. So with our calculation of N, it's going to be N is equal to the number we end at is 10 minus the number we're starting at is K, and then plus 1. And so if you simplify this, this is N is equal to 10 plus 1 is 11, so it's 11 minus K. And we're going to leave that as N. That is our value for N. So we have N. Do we have A? Not yet. Well, we have to find A. Remember, A is your first term. It doesn't mean you substitute 1 in place of your variable in your term formula. Okay, you don't substitute 1 in this case. What you're going to do is this. Because they say P is equal to K, they didn't even tell you where you start at. We need to find out that. Since this is where we start at, to find term 1, which is A, so T1 is A, to find that, you're going to have to say, use your formula, you say 3 to the power of, and in place of P, since they told us we are starting at K, we need to substitute K to find our first term for this particular series. So I'll substitute in place of that K and then minus 1. That's all I have there. And I'm going to treat that as my first term because it is my first term since I don't know what K is. Okay, so we have R, we have A, and we have N, and we are ready to start. So let's go ahead. So we have the sum of how many terms? This is the sum of N, we know is 11 minus K. So I'll call that S of 11 minus K is equal to, our A value is 3 to the power of K minus 1. This is just a case where you just have to trust the process and trust that you actually have found each of the values that you needed to find correctly. And then R is 3. So 3 to the power of, well, we know N is 11 minus K minus 1 all over R minus 1, which is 3 minus 1. Okay, then S of 11 minus K, or really the sum of this series that we're speaking about, is 29,520. So we're going to put that there. 29,520 is equal to, and let's go, we have 3 to the power of K minus 1. And then we have, well, I guess we can just multiply those already. So when you're multiplying, since it's 2 terms inside, it's going to distribute like that. And so 3, they have the same base. So you're going to add the exponents, keep the base the same and add the exponents. If you say K minus 1 plus 11 minus K, you don't need brackets because we're adding. So what's going to happen is you're going to have your K and your K cancel, because they will simplify to 0. And then 11 minus 1 is 10. So we have 3 to the power of 10 there. And then this multiplied by negative 1 will just stay negative 3 to the power of K minus 1. Okay, so there is no confusion there. Remember, the negative is outside. And it's actually this base of 3 being raised to the power of K minus 1. And we have that over 3 minus 1 is 2. Okay, so this is what we have so long. As you can see, K is nicely on its own. We just have to find our way to get to it. So the first thing that is stopping us from getting into k would be this 2. So let's go ahead and get rid of the 2. Since here you're dividing by 2, to get rid of the 2, you need to multiply by 2. But you have to do so on both sides since this is an equation. So what do we have when we say 29,520 multiplied by 2? That gives us 59,040. Okay, and then we have is equal to, and this is 3 to the power of 10 minus 3 to the power of k minus 1. Okay, so this is what we have so long. Let's keep going. Now, what do we have to do next? Well, the thing is, I see that this is negative, and I don't like the thing being negative when it includes the variable we're looking for. So what I'm going to do is I'm going to take that over. Okay, so when I take this over, it becomes positive 3 raised to the power of k minus 1 is equal to, and I'm going to simplify this 3 to the power of 10. So 3 to the power of 10 on the calculator is, we have 59,049. Okay, and what I'm going to do with this 59,040, I'm going to take that one over. So it becomes negative 59,040. Okay. Then we have 3 to the power of k minus 1. As you can see, 59,000 and 59,000 will cancel. 49 minus 40 is 9. So we have 9 there. And so 3 to the power of k minus 1 is equal to, make the bases the same since it's an exponential equation. It's 3 to the power of 2 is 9. And now that the bases are the same, we can therefore say that k minus 1 is equal to 2. And therefore, k is equal to, take that negative 1 over, k is equal to 3. And that is our answer for k. You can go ahead and test it out. You can go ahead and take k is equal to 3 and put it there. And then find your first term, second, and third term. Then find the sum of that series, making sure that you find n by saying top or the end minus the start plus 1, and then you actually find that you will get this number. Okay, so k is equal to 3, and that is it for question 2. And let's move on to question 3. Question 3, we have 3.1. They say consider the quadratic number pattern, which is 3, 7, and 12. So 3.1.1, you have to show that the general term of this number pattern is given by this equation. Okay, so they already told us it is a quadratic pattern. So firstly, we'll just have to find the first difference. So the first difference, you can go ahead and say 12 minus 7, which gives you 5, and then 7 minus 3, which gives you 4. And then find the second constant difference. That will be 5 minus 4, which gives you 1. So now that we have that, you're going to equate these to the following. So the first one, the second difference, you equate it to 2a. Then this first number here in the first difference, you equate that to 3a plus b. And then that first number in the quadratic, you equate it to a plus b plus c. Okay, so how we find that, we just say 2a is equal to 1. And then to solve for a, divide both sides by 2. And so it means that a is just equal to a half. Okay, so as you can see, we actually do have a half there as well. And then we have 3a plus b, but we already know what a is. So that's 3 times 1 over 2 plus b is equal to 4. And then 3 times 1 over 2 is 3 over 2. But I'll just start here. Say b is equal to 4. I still have 4. So that becomes 3 over 2. And if you take it over, it becomes negative 3 over 2. Okay, so quick way to calculate this is you can just make 4 have a denominator of 2. So 4 as a denominator of 2 is 8 over 2 because 8 divided by 2 is 4. So b is equal to, the numerator subtract, the denominator stay the same. So 8 minus 3 is 5 over 2. So there we also have b as 5 over 2. Then to find c, you're just going to say a plus b plus c. So that is 1 over 2 plus b is 5 over 2. C we don't know yet is equal to 3. Then this is going to be, as you can see, the denominators are the same. So that's 6 over 2 and 6 over 2 is 3. So 3 plus c is equal to 3. There's 3 on both sides. You can cancel, or it's like taking 3 over. So that becomes 3 minus 3, which is 0. So C is actually just equal to 0. And so the Tn pattern, the general form is Tn is equal to An squared plus Bn plus C. And so this means that we're going to have Tn is equal to our A value is 1 over 2n squared plus 5 over 2n and then plus 0, which is really nothing. So that is your answer. Okay, so there we have shown that, and that is for 3 marks. Moving on to the next question. Okay, grade 12s, we are finally on 3.1.2, and it says, what number must be added to Tn minus 1 so that Tn is equal to 13,527? Okay, let's think about that. So in order for us to find this, let's actually understand what exactly they mean by Tn minus 1. So for you to understand what they mean by Tn minus 1, you need to understand what Tn means. Tn refers to the last term. Okay, when they're speaking about find the value of Tn, is usually the last term in that pattern. So we're saying if we have a term Tn and the value of it is 13,527. So where is this going to lie? Well, I want you to see that they say n minus 1, meaning the position minus 1. And so if they say Tn minus 1 and we're subtracting 1 from the position, it means we're really just going 1 position backwards. That's Tn minus 1. So if this is the last term, this is your second last term they're referring to. Okay, so how does this now make sense with the question? The question is saying what number should be added to this so that this can actually have this value. So if we're looking at that, they're really asking you what number should be added to this one so that we get this. Do you see now that they're actually asking you for a first difference value? Because for you to get this, you take this one and you add a first difference value and you will get that. So it will be better if we just get our pattern from above here, and this will make more sense with the pattern. Okay, so this is our pattern we have, and we can see that in order to get the next term, for example, in the third term, you have to add a first difference of 5 to get that next term. Likewise, in order to get this number, you're going to have to add a first difference value to this Tn minus 1, right, in order to get that. So ultimately, they're really asking you, because they say what number must be added to that. They're really just asking you for this value here. What value do we have between the last term and the second last term? That's all we need to find. Okay, so to find that, it's actually not going to be so complicated, because all we can first of all do is, since we know this is Tn is equal to this, how about we find out what position number this is? What term number has a value of 13,527? Let's go ahead and find that first. So to find that, you're going to use your Tn formula. Since we knew that Tn is equal to a half n squared plus 5 over 2n, right? So to find the position where Tn is equal to 13,527, you just replace Tn with 13,527, okay? And rewrite that, of course. Then we can just take this over. So this is 0 is equal to a half n squared plus 5 over 2n and then minus 13,527. Okay, so this is a quadratic equation and it can probably be factorized, but I see that there's an issue here because of the 2's that we have on the denominator. So what we can do is get rid of those. And so to get rid of a denominator of 2, it's really just being divided by 2. So you'd have to multiply by 2. So what we're going to do is multiply by 2 on this side and on the left-hand side because it's an equation. So that's going to give us 0 times 2, which is 0 is equal to, and when they multiply, the 2 times a half, the denominators cancel, and you just be left with your n squared. The 2 times the 5 over 2n, the denominators cancel, you're left with 5n. And then the 2 times that, so we just have to calculate that. And you see that when we calculate that, it's going to be negative still, so 27,054. Okay, so now that we have this, we can factorize or pretend to factorize. So open up two brackets and say this is n times n to give us n squared. And let's find the factors here. So you can go ahead and use the quadratic formula. That's what I'm going to do. I'm going to substitute this into the quadratic formula on my calculator. Okay, and the first solution I get, remember that is the solution, meaning the value of n is 162. And so if this is a solution, then it means that your value of n is actually supposed to be, or your factor, sorry, is n minus 162, because it's like taking 162 over. Then we change that plus to a minus, and we get negative 167. Remember, that is your solution. So n is equal to negative 167, and so it means that your factor is n plus 167. Okay, so just already from this, you can see that the negative 1, we cannot accept that because terms are never negative. Terms are positions, okay, like position 1 and 2. They kind of work like things like days. They count on, they move, and they're not negative. So it's like day 1, day 2, but you cannot get day negative 5, okay? So n is equal to 162. That means that T162 or term 162 actually has a value of this 13,527 that they were referring to. That's the Tn. Okay, we know what that is now. That is that term 162 with 13,527. Okay, so how can we use this to get to where we want to be? This is what we want. We want the value of this. If this is term 162, so now we know, okay, this is actually term 162. Then that would mean that this Tn minus 1, the second last term, would be term 161. And so what term would this be? Well, you can remember this by looking at this. For example, you see, look at the third term and the second term. The arithmetic value, okay, the arithmetic term between the third and the second term is the second term in the arithmetic pattern. There's your first, there's your second. So that's an easy way to see that. If you have between term 3 and term 2 in your quadratic, then we will have term 2 as the number between these two terms. So if this is term 162 and this is term 161, then what term is this? This is term 161. Okay, so if we know the term now, and I think we should just be updating them and letting them know. So I first of all tell them that it means that Tn minus 1 is equal to 161. And now we know that the term that gets added is the 161st term. So to find its value, you're just going to have to substitute term 161 into the formula of your arithmetic pattern. And we can easily find that formula by using its Tn formula. So Tn is equal to A plus n minus 1 times D. And we're just going to substitute what we need to substitute in order to find that. Okay, so now that we have this, we're going to just say this is term 161 is equal to our A value in our arithmetic pattern is 4. Okay, so we're going to say it's 4 plus n is 161 and then minus 1, of course, and then our difference, okay, our constant difference was 1. So, and then we just have 1 there. Okay. Okay, then the answer here, you can just say, you see 1 times anything stays the same. So it's really just 4 plus 161 minus 1, which is 160. And as you can see, that's going to give you 164. Okay, so it means that the value, the number that was added to Tn minus 1, to that value was that 164. Now we know what that value is. It's 164 that was added to this in order for you to get that over there. And then I'm just concluding. So the number that was added is 164. Okay, so that is it for question 3.1.2. And we finally move on to the next question. Okay, so 3.2 says, given an arithmetic sequence with term 1 being equal to 8 and term 2 being equal to 11. So we have 3.2.1. Calculate the value of n if Tn is equal to 41. Okay, so they've given us enough information, Please remember that T1 is also the same thing as A. And we know that this is an arithmetic sequence. So we just have to find n if Tn is equal to 41. So I'm going to treat T1 as A, and I also have that information. So I guess we can use that to find D. So our formula for an arithmetic pattern is Tn is equal to A plus n minus 1 times D. And so I know Tn is equal to, and I have my A value as 8. So that's 8 plus n minus 1 times D. But I can just go ahead and substitute T2, which is probably what I should have already done. So I'm going to say T2, okay, let's just rather put it in here. T2 is equal to 8 plus 2 minus 1 times D. And now we know the value of T2 is actually 11, okay? So T2 has a term value of 11. So it's equal to 8 plus 2 minus 1 is 1. 1 times D is still D. And then to solve for D, you leave D here and say 11 minus 8, which gives you 3. So we now know what this is. D is just equal to 3. And so since we know what D is, we can go ahead and find what they asked us to find. They asked us to find the value of n if Tn is equal to 41. Okay, so what term has the value of 41? So Tn equals, and we're going to say we have now 8 plus n minus 1 times 3. Okay, now Tn, we already know what that is. It's 41. They told us that. So we'll say 41 equals, and you can go ahead and start by taking 8 over first. So if you say 41 minus 8, you're going to get 33, which is equal to, you see that these two are being multiplied. Since this is the first, it's just one term, right? You can put it in front. So it's 3 times n minus 1. Then you can get rid of the 3 by dividing both hand sides by 3. And then 33 divided by 3 is 11. And we have n minus 1. If you take the negative 1 over, that's 11 plus 1 is n. And so therefore n is equal to 12. So now we know what that is. We know that n is 12, and that is our answer for that question. Okay, moving on to the next question. Okay, so 3.2.2 says, a new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. So of that one. So they say for the new sequence, we have P8 this time being equal to 1 and P11 being equal to 2. So this is P8 and P11. Okay, and so forth. Write down the value of P41. Okay, so since they said using the term position and term value of the given arithmetic sequence, let's look at the old one first. Okay, so we'll look at the old one, okay, the old sequence, and we'll also compare it to the new sequence. So the old sequence that we had, this one, what they told us was that T1 was 8 and T2 was 11. So if T1 is 8, T2 is 11, then the new one, let's just call it new sequence. The new sequence, they're telling us that this is what they have here. Instead of T, they have P, and they have P8 being 1 and P11 being 2. Okay, do you see something similar with these? Do you see that what they actually were saying, they mentioned that the term positions and the term values, right? They use that of the given arithmetic sequence. Do you see that they just swap places? T1 now has a value of 1 in your new sequence, and P8 has a value or had a value of 8. They really just swap the position number with the values. Okay, so that's actually what's going on here. And it's interesting that they ask you for P41, because you see here that it asked us what n was if Tn is 41. Okay, so in that case, since we know that T12, right, is equal to 41, since we can see that these ones are swapping, if T12 is 41, then P41 must be 12. Okay, and this would really work like this especially because this is an arithmetic sequence. And the thing about arithmetic sequences is they would still be consistent with their difference, okay? The common difference in these two patterns may not be the same. True, that they will not be the same, but the common difference is still going to be exactly the same. Like if you go from P8, right, and you go to P9 and P10 and P11, you'll notice that the common difference would stay exactly the same. And so because of that consistency, it will help to actually swap these like that. Okay, so for this one, P41 is just 12. Okay, so I'll just tell them, therefore it means P41 is equal to 12. And that's probably why it's 1 mark. So they wanted you to see that. They just swapped it. Okay, we move on to the next question. Okay, so the last question is calculate the value of the first term in the new arithmetic sequence, in the new one. So they want us to find A in the new arithmetic sequence, and it's for 4 marks. So it's really just calculations we have to do. Let's just use what we know about the old arithmetic sequence. Now, unfortunately, we don't know what the first term is because they're asking us what the first term is. However, we know that in the new sequence, we have P8 being equal to 1 and P11 being equal to 2. So from this, despite the fact that these two terms, they don't really come directly after each other, okay? But there's something that I mentioned in that previous question now. You see, the thing about these terms is, yes, they don't come right after each other, but we know there's a P9, we know there's a P10. And the consistency between them is that you're going to notice that what you keep adding or subtracting to get to the next term is going to be exactly the same. So why don't we just call that D? I'm going to say that we're adding D. So we're going to go from P8 and add a D and get to P9, right? And then from P9, add D and get to P10. And P10, add again D and get to P11. So it means that from P8, which has a value of 1, you just have to add how many sets of differences? 3. 3 differences to get to P11, which has a value of 2. And we can use this formula to find the value of D. So that means 3D is equal to, we have 2, and we're going to take 1 over, which becomes a 1. 2 minus 1 is 1. And then divide both sides by 3. And so we know now, okay, D is equal to 1 over 3. Okay, we have enough information now. So we have enough information to finally find the value of A. So since that's the first term, of course. So to find the first term, you can just use the Tn formula. Tn formula is Tn is equal to A plus n minus 1 times D. So we don't have A, that's what we're looking for. We have D, and we just need something to be filled in for Tn and n. To do that, we can just use one of the terms we have already. So to be safe, well, you can use anyone, it's going to be fine. But let's just say we decided to use P11, okay? You can use anyone in this case because there's no P1, so it's fine. So P11 is 2, and I'm going to use that. And I call this Tn, but I should call it Pn since it's this formula we're talking about. Since we know that P11 is equal to 2, we're going to substitute this into this formula. So we're saying that P11 is equal to, we don't know what A is, and we have plus, our n value is 11 minus 1, and our D value is 1 over 3. And then we have P11, which is 2, is equal to A plus 11 minus 1 is 10, and then times 1 over 3, of course. 10 times 1 over 3 is just 10 over 3. And so to find A on its own, just A, you're just going to take your 10 over 3 over. So 2 minus 10 over 3 is equal to your A value. Okay, so 2 minus 10 over 3, I don't like to reuse calculators too much. So I'm just going to change 2 so that it has a denominator of 3, and I can change 2 into 6 over 3, because 6 divided by 3 is 2. And so 6 minus 10 is negative 4. So it means that A is finally equal to negative 4 over, and the denominator stays the same. And that is the value of A. Okay, so there we go. The memo is not really out yet. So if I do make little mistakes here, please do point it out in the comments so that I can look into it. And maybe I'll like post an edited version all together as one video, because I am releasing these as separate videos. Okay, so that is the end of question 3. Question 3 is 15 marks. And in our next video, we will finally move on to functions, which is question 4 to 6.